Okay, I'm going to try to amaze you. I mean, when I amaze myself, usually I amaze other people, one or two. But remember, we've been saying now for over a year that 2023 was going to be a very telling year in terms of X-rays. We said that the X-rays were probably going to go up 100-fold from what they were a few years ago. 10 to the minus 7 from 10 to the minus 9. That's a exponential scale. So you go up two numbers, that's usually 100-fold increase in just the background level. This is where the X-rays are bottoming out at. So we were warning that they would be that high in 2023. That was our prediction, and it was really not even a prediction. We were telling you it was going to happen just because it has to happen when you have all the variables to a physics equation. So here we are. It's not even 2023 yet, and we're almost right at 10 to the minus 7. So when you compare that to the other background X-rays that we've been showing you over the years, these are high energy X-rays. These are almost, you can consider gamma radiation. And so, yeah, it's here already. So if that amazes you that, we're the only people on planet Earth that appeared to know this was going to go on, that's amazing, isn't it? No, you're not amazed? Okay. Well, here's another prediction. We predicted that the solar wind was going to get faster 3 months ago, 4 months ago. We were talking about the intermittent mixed speed, the intermittent mixed temperatures, the intermittent mixed densities that were showing up on this instrument. But now look it. We told you when we got downwind, if we knew where planet X was, if we got downwind, that the baseline solar wind would go faster. Well, at that time, we were averaging about 350 kilometers a second. Well, I mean, for 2 weeks now, we've been hovering at 500 kilometers a second, right on time. And who else told you that was going to happen? Nobody else on the planet Earth? Just this channel? Now, hey, that's amazing. Here's something else amazing. That middle pie-shaped cut on this simulation. This is the magnetosphere. And these are CMEs coming off the sun. That pie cut is north to south. So your Earth is moving away from you. That little yellow dot in the middle of the pie cut. Okay, we have a CME, actually a coronal hole stream, come washing through, and something bizarre happens. Einstein and Newton just rolled over in their graves. They're jumping up and down, saying, wow, that wave in some portions went up 3 units of particle density. It starts out as green, goes to yellow, turns to red, and then white. Yikes! That's a huge increase in density there, headed down towards the bottom part of that pie cut. But even the upper portion of that wave, as it gets to the outer reaches of that simulation, boom, green turns to yellow, and then the yellow turns to red. Now, you guys, that's amazing. You take a handful of gravel and throw it. Throw it underhand, overhand, sidearm. Throw it fast, throw it slow. Do it a million times, and each and every time, the particles that coming out of your hand will decrease density over distance and with time. But not here, not in our local, very own solar system. No, we have to come up with new physics to explain what's going on, or we simply state the obvious. Higher truth said we were going to be downstream of that brown dwarf. And all of a sudden, what happened? The wind speed increased. So the second wind is now mixing better and easier with the sun's wind, traveling in the same direction. The focusing cone is outside the range of Earth, thank goodness, where those particle densities just triple in a very short distance. So obviously, we're downstream in the focusing cone. Amazing, just amazing stuff. I just, I surprise and shock myself sometimes, and I'm pitching myself right now just to make sure that I'm not delusional, which half the time I could be. So I'm looking through the chronographs on the left as I focus on the. Look at the top of your screen. Watch what happens here. This is crazy. Look at that. What is that? Headed towards the sun and into the sun. Well, first when we saw these, we called it matter impacting the sun. It got a lot of hits. But then we saw it as a collapsing cavities. But what happens though when these things usually collapse into the sun? It triggers high speed and immediate coronal mass ejections. Boom. Fast, immediate, spontaneous, boom. But the collapsing matter racing into the sun is coming all along the 9 o'clock position, the 10 o'clock position, the 11, and even the 12 as we showed you earlier. Incoming matter coming into the sun, sometimes faster than the CMEs are leaving the sun. What the heck is going on? So now I'm going through a bunch of flares that happened last week. And I see right at the 9 o'clock position, we see a collapsing, it looks like a sphere hitting the sun. There's several of them coming in. Some of them are more darker shadowed. Some of them are grayer shadowed. It just depends. But, go back and watch this again and stare at the 9 o'clock position on this set of images, and you'll see something momentarily fly into the sun. And then here, this is crazy. It looks like the sun is just getting pelted from 9 to 12. We just have all kinds of collapsing movement headed inwards towards the sun, not just the 9-10, but 11, 12. We see, and triggering shock waves. You can see the rings of shock waves coming off the sun. And look at that collapse. That's just crazy. That's more than I'm used to seeing. And I don't know what's going on. I don't know what causes it. But what I do know is that it triggers chain reactions on the sun. And back in 2012 and 13, when we actually, even 2014, we started making videos about matter hitting the sun, strange objects hitting the sun. But now, as time progressed and we watched, we thought it was collapsing cavities focused by the inbound magnetic field lines. Magnetic field lines are coming and going. And we show you a lot of times these active regions pulling in matter from the corona or also from another surface filament. It just pulls them over across the surface of the sun, and it seems like it's raining plasma into and onto the surface of the sun. It's so cool when that happens. But that's all near the surface of the sun. What I'm showing you is happening way far out in the corona of the sun. Some of this stuff originating almost completely and totally off screen. That's just crazy stuff. So, I went through and just found, big shadows moving in. We'll try to point some of them out, but everything's supposed to be moving away from the sun that you could pick up on a chronograph. But we see very high speed inbound mixed with medium speed inbound movement. And here's the thing, it's only on one side of the sun. But just on the opposite side of the sun, up about 30 degrees and way behind the sun. Out towards the wall behind your monitor. That's where Planet X is, up 30 degrees from your monitor. But so that wind is still coming down at an angle, but more at us now. And so I'm going through and notice again in the chronographs for the last several years we've seen flashing, just in the background, image. And we see this now more and more on all the satellites. It's common to more than one satellite. Flash, flash, flash. Stereo A has been flashing for a long, long time. But so now on the 20th, so we're, it sure seems like we're going to be downstream of that focusing cone. And what happens is increased heart palpitations, increased headaches, increased ringing in the ears. Also, your dreams sequences may get a little weird. It seems like all that's kind of been softening. Last year at this time, I didn't have the vivid dreams that I had 2 years ago, coming into May and June, when we put that brown dwarf opposite the sun and us. So I mean, I don't know who else is bringing you this and telling you about it before it happens. I don't know how many people were telling you that background x-rays were going to double, and now they've doubled. I don't know who else has done that, but it's very, very telling, because it kind of explains everything else that's going on around planet Earth, and even how mankind seems to be behaving now. But last but not least, look at these complicated field lines. They're not uniform like a horseshoe. They're crisscrossing, and usually that means there's a second magnetic field influencing the stream of electrons. And about that flashing, this instrument doesn't flash, but this one does, and it affects the entire frame. And we have more than one wavelength that does this. And this is really high energy. So what I'm thinking is that there's a particle density issue, and Shadow Burn, kind of like his channel, he was talking about particle density in lightning. When you put all these particles, metallics, in the air, and all this freaky lightning that's actually more powerful than it's ever been. And he's talking about the particle density and the conductivity of air. And so, the particle densities here are up to 20 particles per 1,000th of a centimeter, a cubic centimeter. So and helium is the most effective. Are you ready for this? Helium is the most effective and efficient conductor of electricity in the entire universe. So if you have helium densities that are 20 particles per 1,000th of a cubic centimeter, you're talking hundreds of millions of particles. So then imagine the conductivity of just the air. And and so what we're seeing on the sun is mimicking a lot of what's happening on Earth, where we're having crazy lightning that now, saws a car in half. Why? Because the car is grounded now because of the high density of metals in the water. And so if it's really wet and the water's up, to the axle, lightning hits your car, all of a sudden your lightning goes through your car now. So I really had been contemplating that's what we've been seeing in the flickering sun. Look up, just type in flickering sun, and there's people shooting videos at football games and soccer games, and the sun is just flickering. And people are commenting why it's flickering. And I think that's what we're seeing, is we're seeing these active regions flash. They flicker all the time. And because now of the particle density, they're becoming connected to other magnetic fields and out into the corona, where particle densities are tremendous. And so all of a sudden we have, not only do we have more helium, but we also have more electrons. So having more electrons and having a stronger current and using helium as your conductor, then you're efficiently transferring those electrons almost at the speed of light now, or almost no resistance. In fact, there's almost zero resistance. So when these active regions flash, then it will have like a neon light effect with the rest of space. The space could light up, and we've starting to see. Please, somebody link the video if you know what I'm referring to. It's an amazing video of, like, people call it a plasma ball. I don't know what it is. I think I know what it is, but I don't know what it is. And very high electrons. People's hair was standing on end. A big ball in the sky, lightning all about. It was a scary movie, and people were freaking out but laughing very nervously at this, what they were termed a plasma ball. I don't think it was a plasma ball, but I couldn't tell you. I couldn't tell you for sure. But it was a freaky video. Please, somebody link that video. Somebody sent it to me, and now I don't have it. But that would create flickering. And now, articles are coming out, and we thought this might happen. If you have more particle density, and you have electrons that are just flashing and ripping through the air, right? Because you have metallic oxides, you have helium in the air, which never hurt lightning. And all of a sudden, you have more electrons, so your lightning is hotter. And so you're splitting more atoms, and you're involving more and more electrons. That's going to create gamma radiation. Because electrons are a source of gamma radiation. They can be. So now we see articles about lightning creating gamma radiation. So with these higher densities, you have to figure incredible lightning storms are going to be a little gamma ray party. So take measures accordingly. And we're going to show you how we make really inexpensive panels. Cost about $3 a panel, maybe more now, maybe $5. How to just make a gamma radiation proof panel. Very inexpensive, but it involves layers. The theory of layering, which is what they use for armor now. But listen, what's going on in the solar system is affecting mankind. And so you can expect there to be a lot of behind the scenes peddling, a lot of dog paddling, a lot of running around, a lot of activity behind the scenes. You can expect government doing things that you would never dream of. You can expect all kinds of legislations and setups designed to enact laws that they're going to enforce that are totalitarian and authoritarian. So that's kind of what the Bible warns us is going to happen. So it shouldn't be a surprise when it's just logical that that's what, the kings and queens are going to try to survive this upcoming and rolling cataclysm. But things are happening very fast. And the diesel fuel thing is a heartbreaker. So until next time, well, thank you for listening.